that steam turbine concept at the local site is going to be super critical. Yeah. Because we don't have enough grid to do what everybody wants to do in terms of electrification. And we don't have it where it needs to be to get the renewables out. Like the central part of the United States is where all the best renewable opportunities are. And we don't have an infrastructure to take advantage of that and move it to where all the people are located. So that's going to have to change, and that's going to take quite some time and quite the investment. But we seem to be going about that by putting all these renewables in some place without addressing the infrastructure. Vermont is the greenest grid in the United States, and they have turned down solar projects because they can't put any more electric on their grid. So as much as they'd like to be more green, you can't be it if you can't deliver it.
The High Fire Podcast is your go-to for straight talk on the steam and boiler industry. Get knowledge you can use, stuff that matters, like tech, safety, industry trends, and more from steam industry experts. Tune in and stay fired up.
On this episode of the High Fire Podcast, we look at the future of the steam industry, predictions and insights into the future of steam power and its role in global energy systems.
Welcome to WARE's High Fire Podcast. We appreciate you coming back. And today we're actually got our panel with us, and we're going to be talking a little bit about the future of the steam industry. There's so many people that talk about the steam industry and how like it's dying, and but there is a future. So, Steve, I want you to just kind of start with yourself, introduce yourself.
Yep.
Move on.
Steve Taylor, run the rental division, been with the company for 42 years, started in the shop, worked my way through the business.
I'm Gerald Blaine. I'm the director of our projects and services group. I've been with the business for 21 years.
I'm Brent Falcone. I've been with the business for 30 years, and I'm a director of people and culture.
Nice. I'm Richie Ware, and I'm the president of the company, and have been here back to the company for 29 years, but obviously been around it all my life. And a little fun fact, I enjoy baseball. What do you?
I do, and eating.
And eating.
Enjoy that.
Catch any fish this week?
Man, I went yesterday and it was awful. It was a wasted effort. It was just absolutely awful. I still enjoyed being out there, always do, and I'm standing on the front of that Ranger bass boat powered by that 300 horsepower Mercury.
That's doing a commercial.
The plug. All little ratch controls on there. It was
like the same sponsor.
Yeah.
Where is the sponsor? Don't forget that.
Yeah.
How many times you won a state championship?
Two
times.
Angler of the Year, 4.
Angler of the Year. What does that mean?
It means you're the top angler in the state.
State of Kentucky.
Yeah.
Okay.
I've been to the Nationals twice.
Right. And biggest bass that you've caught?
8 pounds, 13 ounces.
Done a little bit of a fight?
It was fun. Caught one. I actually caught 2 of them that size in Florida. One flipping, which means you just pitched it out there and let it fall.
Yeah.
Is it flipping or pitching?
That one I was flipping.
Flipping.
Yeah. Because flipping, you just pull the line up, pitch it out there, and pitching, you actually pitch your way out there. But he wasn't 5 feet from the boat. And I caught one on a rattle trap in Florida, and that was a whole lot more fun. It took a lot to get him in.
Yeah, it's awesome. Well, the future of steam and the industry, where's it going? Steven?
Steam's not going anywhere. How it's produced, that will change and evolve over time as it has, and since the beginning of making steam, it's evolved, and it'll evolve some more. They'll find different ways to produce the steam, but the steam as a heating medium is not going anywhere. They haven't. They've been working for 100 years trying to define something to replace it with. And they haven't been successful, and I really don't see anything in my lifetime. There won't be anything that they'll come up with to replace it with.
Yeah, definitely not in my lifetime, but it's just too efficient of a carrier.
Yeah.
Unlike, hot water as an example, carried 212 BTUs in a pound, where we're putting 1,000 BTUs in a single pound of steam. It's just, there's no other way to move that much energy.
Right, right. But there are some advances, obviously, in the boiler itself. And so, are there some new things from a materials standpoint, any type of innovations in control systems, things like that, that you're seeing?
Yeah, again, the control systems will change. They've adapted and huge innovation in the controls over the last 30 years, especially the last 15. Burner technology has changed. So how the steam is produced will change, and that's evolving, becoming more efficient, lowering emissions, doing all those things. But the steam itself, it's going to be here.
And they have improved materials, like you mentioned. We got XID tubes or rifled tubes as an example. I mean, they produce 85% more efficiently than a bare tube, and they add about 25% more square footage in a single tube. So, and then fin tubes as an example, it allows the heat transfer to be that much more efficient.
Right.
Which in a lot of cases, this is reducing the size of the equipment, not necessarily taking it that much more efficient. Right. So
you could really just kind of look at that in a rental fleet with the XID tubes that you're talking about. And, there are some changes there because it seems like boilers are getting bigger and bigger inside of a trailer.
The capacity is getting bigger because the boiler itself.
The boiler's getting smaller. For the capacity, I should say. Yeah.
Yeah. We,
So stretching those things out a little bit.
Yeah, we're 1,000 horse, and that's become the most popular size in the rental fleet now. And if I could put 2,000 horsepower in a trailer, that would be the most popular size in the rental fleet. The customers want more power and smaller package, the same size package, they can move down the road.
Yeah. And they're actually, even on the water tube side, we're starting to be able to get up into the mobile, about 100,000 pounds.
100,000 pounds an hour,
It's actually
same
added
footprint.
to the fleet.
Yeah.
Talk a little bit about that.
Yeah, we just added 3 units to the fleet that are physically the same size as our 82,500 pound per hour units, and they're 100,000 pounds an hour at 30 ppm, and the job they're on, we're doing 85,000 at 7 ppm. So, and the burner technology has changed dramatically. We've put the fin tubes that Gerald mentioned in the turnaround section of the boiler, so we're getting a lot more heat transfer with the using the 1.5 tube instead of 2 inch and putting fins on it. You're just getting a lot more heat transfer, so reducing our exhaust gases and putting that heat from the gas into the steam instead of shooting it out in the air.
Yeah, and it's incredible. Over the time that I've been here, it used to be the 75,000 pound an hour water tube boiler for rental that we would always everybody in the industry had.
Yeah,
and it just continues to get bigger and bigger from a mobile standpoint.
Yeah. When I started in the business in '82, 30,000 pounds an hour was the biggest thing they put in the water tube and get down the road.
Oh, really?
Then they went to 52, then they went to 60, and then 75. Then 82.5 was the most popular that everybody put together. Now we've bumped it to 1,000, to 100,000.
100,000.
Yeah.
No, that's awesome. It's incredible just what keeps coming out. Let man kind of create, think, innovate. And you take something that's old and old technology and continue to advance it.
Business thinking. I wonder what do you think the biggest changes are around the boiler? Like, people have been turning wrenches around boilers for years. Is it just the combustion analyzer? Like, what are the metallurgy, the way to test it? Things have been growing and changing around boilers, not just the boiler itself. We talked about controls, but I was like, man, there's also other things kind of industry-wise that are changing. Is it the same tools, same old tools guys are rolling in with?
There's a little bit of difference in them, but not a lot. Because it used to be, you turn that roller in there with a wrench. Well, then they went to electric motor, and then now they got big air motors, and then they got machines. You set it up there, and it'll roll them all.
Yeah.
But the way it's being done is the same. Just some of the technology, some of the components to do it with have changed. They have automatic welders that seal welds the tubes. You put it in there and it seal welds the tube. You don't have to have a guy sitting there like I did, years ago and weld it by hand.
yeah, robotics has definitely improved the process and how the welding in particular is getting done. And the designs have changed to some degree. The water tubes today were tangent tube before, where the tubes were butt together, didn't have as good of a seal, and now they have the ligament between the tubes to seal it off completely. So there's been a few minor changes.
Sure.
But at the end of the day, it's metal with water in it, heating it up.
Yeah, that's right. Giving us the good old steam.
Right.
Well, the future, that's something that's actually impacted, I think, the industry is some of the buzzwords of decarbonization is something that continues to be talked about. Obviously, sustainability is one, but now, of course, with us being owned by Armstrong, circular thermal is really the words that we use and talk about, instead of just a decarb thing. It's still decarbonization, but it's circular thermal is really what they're doing. But how is the role of steam going to be used in decarb?
I think what we focus on is, more and more heat recovery of that. Let's use the steam more efficiently. A lot of times it's a one-way street on it, and we've wasted a lot of energy that we didn't have to waste. So that's been our big focus now is, we've always focused on heat recovery, but it's going up to another level, like Armstrong has their heat pump, which is a whole different way of thinking about heat recovery, where we're taking low-grade temperatures and creating higher-grade temperatures, including converting it to hot water and or low-pressure steam. So it's just another element in our heat recovery system to try to complete that circle, which is where the circular thermal comes from.
Another thing that we're doing, and Gerald's much more into it than I am, the rental department, it's really not an item that we even talk about, but where we've used steam pressure reduction stations to drop steam from 200 psi down to 5 psi for the deaerator tank or the process, instead of using that PRV and losing that BTU and wasting it. Now they're putting a steam turbine there and running it through it, using the low side of it for the exhaust for the low pressure steam, and then turning electricity, turning pumps to pump water, doing whatever it is. It's all free. It's free energy that producing just by reducing the steam pressure.
Yeah, and I think in the near term, that steam turbine concept at the local site is going to be super critical.
Yeah.
Because we don't have enough grid to do what everybody wants to do in terms of electrification, and we don't have it where it needs to be to get the renewables out. Like the central part of the United States is where all the best renewable opportunities are, and we don't have an infrastructure to take advantage of that and move it to where all the people are located. So that's going to have to change, and that's going to take quite some time and quite the investment. But we seem to be going about that by putting all these renewables in some place without addressing the infrastructure. Vermont is the greenest grid in the United States, and they have turned down solar projects because they can't put any more electric on their grid. So as much as they'd like to be more green, you can't be it if you can't deliver it.
Good.
So we've got a big problem there.
I was reading something the other day talking about the infrastructure. In 2012, there were 1,700 miles of new grid installed in the U.S. In 2019, there was 15 miles put in.
Right.
So they've completely quit putting, and they're talking about all this, electric cars and electrification, but they're going the opposite direction on putting new grid in to get all that, to your point, to get it out to people where they need it. So,
And so the idea of eliminating steam, particularly high pressure, makes that worse because then you've got to try to replace that with electric, which is quite a bit more expensive than utilizing steam. So you've got a double-edged sword where, okay, every time we try to reduce steam, we've got a bigger electrical problem.
Yeah, I do.
So, like I said, in our lifetime, we'll never see it.
no.
I don't imagine we'll ever see it regardless. It'll just come in different front ends. Might have a nuclear to be the nuclear is a steam process.
Right.
So
Right.
they're all different things.
If you're like trying to fix the problem, and let's just say with right now, the fastest way we could fix it, it's probably nuclear. right?
It would be, and you would still have steam.
Yeah, I mean, so
We would just be.
But the way to
doing it
produce
nuclear.
steam, the most efficient way to produce it is nuclear.
Yeah.
which France, they thought all nuclear.
Yeah.
Right.
There. So, I mean, that's kind of what I've always thought, but I think it's good to have a balance as well, where you have some natural gas and you've got some nuclear and you have some renewables, kind of just have a balance, but to just all of a sudden,
And then you got the big hydrogen story.
yeah,
And there's a lot to that people don't understand. That's why you're starting to see some regulation of about 25-30% mixed to natural gas. Because the problem with hydrogen isn't that it doesn't burn clean, it does. It's back to infrastructure again. You put it in a normal gas pipeline infrastructure, it's a super small molecule, and it will find out any flaw in the materials. Mostly it seeks out fasteners and things like that, and then you have stuff starting to come apart. And then you have a whole nother set of problems.
Yeah.
So even though it's got all this buzz, it's another infrastructure problem.
We just worked on a rental project 2 weeks ago, and I checked with the burner manufacturer. And we could burn; it wouldn't burn 85% hydrogen, and the burner will handle the hydrogen, but nothing that carries the hydrogen to the burner will handle it.
Right.
Because it all has to be seal welded, all has to be stainless steel. There's all kinds of things you have to do. Because any threaded fitting, 85% hydrogen is going to go right through the threads.
Yeah.
You can't seal it.
Yeah.
I know we actually saw when we were in Florida about the cracker, was it the ammonia cracker?
Yeah.
Yeah.
Yeah, and that's going to be interesting to see how that all shakes out, because that's the other problem, is how to transport and deliver the hydrogen wherever you're going to send it. And supposedly you can reverse the process of ammonia and crack out the hydrogen with a minimal amount of energy, supposedly. The problem with it currently, and whoever makes it to the end of this road will be very successful and very rich, is they can't either make it fast enough or enough of it in the current processes. So they're working through that. It's an interesting idea, but it's got a ways to go.
You were talking a little bit about Armstrong, and you really didn't expand too much about the heat pump, but there is a lot of energy that is wasted in each one of these plants, and I've heard upwards of 30 to 40%
Yeah.
at each plant
Yeah.
that can be recovered,
Right.
if you would. You mentioned, recovering the heat. Maybe there's some different technologies that you all top of your head of recovering
Yeah.
with the heat.
Well, the problem when you say that 30-40%, which is true, and the only reason it is that way, it's always been very ROI driven. And some of the things that can recover it are pretty expensive. A heat pump is not cheap, especially an industrial level one.
Right.
But we are seeing more and more companies say, look, we're going to bite the bullet and we're going to go ahead and do it because it's the right thing to do. ROI is a little different, looked at a little differently than it has been in the past.
Yeah.
So,
Yeah.
Yeah, something's going to push a whole lot of that too. Is these bigger corporations that are worldwide corporations are getting carbon tax credits from overseas that they can write off this new expansion to do things, to put in the high efficiency stuff, to put in the condensing economizers, the condensing boilers that brings the outlet gas temperature, exhaust gas temperatures down to ambient temperature, because they're doing so many other things and they're pulling all that heat out. So that it's not cost effective to do it without those credits they bring from overseas.
right. Yeah, we've even had some customers put a dollar sign to CO2 reductions,
Yeah.
but they're not real. They just sign that and say, okay, the project passes because we added that extra value.
Isn't it?
So it's interesting to see what everybody's trying to do.
Yeah, and a lot of the green push, the companies, the bigger companies have put a mandate through that we're going to reduce our carbon footprint by X at this time frame. So the projects that don't make sense from an ROI standpoint are being pushed through. ROI, return on investment, they're being pushed through because they're allowed. It enables them to meet those company goals and move forward.
And we've even had other customers, we've got several projects on hold that wanted to put in electrical boilers that, produce steam again. We're still making steam, but we're doing it with electricity. And the electric companies shut them down because they don't have grid infrastructure to support it. So all these deadlines that are out there are fictitious for the most part. They're not going to hit them.
Yeah.
But I guess you got to start somewhere.
Yeah, so
Right. Which I think you can look from a steam standpoint. I mean, I would think that if you're wanting to talk steam reduction, you would probably talk low pressure steam. And change it from steam to the hot water.
You could do that. You could do hot water, or you can even produce, like with our heat pumps, we can do low pressure steam.
Yeah.
So,
yeah, converted.
Yeah.
There's high temperature hot water and convert it to steam.
yep.
Yeah.
Well, same thing.
How's that actually work? The heat pump, when you're saying that, kind of maybe just go through that concept a little bit further.
It's similar to like an organic Rankine cycle concept where you have this medium that boils at a lower temperature. And then from that, we're able to heat something up, whether it be the hot water or convert it to steam, because of all these different medias that are out there that you can use. So you pump it from one side, condense it on the other, and it goes back and forth to create that delta T.
Yeah, that close to. And then from that, you can get the steam, but you can also have the heat pumps that just do hot water.
Yeah, for sure.
Right. And that's probably the thing that we're seeing more and more of is people talking about hot water for their applications.
Yeah, we've done a lot of business with NYCHA, New York City Housing Authority, and they've talked about doing that in all their buildings they've got out there. But what they've the engineers have come back to them and told them, and it didn't take us about 30 seconds to tell them it wouldn't work, but they had to pay somebody to tell them it wouldn't work. They've got all the piping, all the infrastructure in the buildings. There's no way without tearing the buildings down to take that steam pipe and condensate return pipe out and put hot water pipes in. Because hot water pipes have to be so much bigger to carry the same amount of energy than what you can do with steam and condensate return. They physically can't do it in those buildings. So their long range plans tear the buildings down one by one, put them back up and put hot water in them, but they can't do it with the existing buildings.
With all of these heat pump or hot water or whatever, I mean, that's always seems to be the tension, and that there's always a trade-off.
There's always
always a trade-off. And that's been happening for 30 years I've been here.
Right.
Always a trade-off.
And the hot water, you got so much weight that you're dealing with. Now, like in those big buildings, they've got to get domestic water up there. And they can't afford to do it for the heat side as well because the infrastructure is just out of bounds. So steam, and it travels on its own. It's already under pressure.
Yeah. You don't have to pump it.
Right. So it is just, they haven't come up with a way to do anything more efficient and be more productive than steam. I mean, it's going to be around a long time.
It's kind of a crazy cycle because some people would say, then why don't we just solve the back end? Why don't we just clean out the combustion? Because all the trade-offs aren't worth it. We keep coming back to it's still steam.
It's just still, and you can do that. There's technology to do that, but it's much more for the plant, for the envelope. It's much more efficient to work on burner technology and heat recovery and to get those exhaust temperatures down than it is trying to clean it up. Much more efficient. If you clean it up, you've got either urea or ammonia, then you've got ammonia slips, so you've got those issues going into the atmosphere. So you're really not, again, anything you do, there's a trade-off.
Right.
There's some type of trade-off.
Maybe try not to create the same problem in the first place.
You'll gain here. It's, you're at the balancing beam. If you do here, this side goes down. It's a balancing beam.
Yeah, and I don't think there's nothing wrong with pursuing renewables. It's just, we've got to be more practical in our approach to it. One, we haven't started with grid, which is most important. And then two, renewables aren't great for everything. And not everybody has it. Like I said, our renewable infrastructure is in the middle of the United States, but we have no way to get it out to where all the people are at.
I think that's a bit of the narrative problem too, is adding renewables and reducing
Waste.
waste and reducing, our carbon output and or footprint. Usually the narrative is not, hey, we need a bigger dose of this, renewables, and a smaller dose of this, carbon, emissions that are, producing carbon. It's usually just, we've got to go to this and get rid of that,
Right.
which is not a reality.
No.
And it's kind of a miseducation of the public
Right.
to understand that. Sure it is. So to not villainize one and understand as one grows, one may diminish, but to eradicate it is an insane.
Right.
And anything they say, we're not going to do this anymore after this date, you could, that's politics talking. It's not going to work.
Right.
Watch your mouth. That's all. Very good. Well done.
Yeah. I mean, really, all these type of renewables and stuff. I mean, it's government subsidized.
It's all government
It
subsidized.
actually makes it
The
financially.
The ethanol industry,
Right.
it can't sustain itself. It can't compete with gasoline or any other fuel on its own without the government
Yeah.
putting subsidies in it. And if you look at the renewable side of it, what kills me, they take these renewables and they don't worry about the NOx emissions on renewables because it's renewables. The NOx emissions, because they have to burn that stuff so hot to get it to burn,
Yeah.
their NOx emissions go through the roof.
Right.
They don't pay attention to it.
Well, just for instance, like, and again, not knocking the,
No.
the wind energy, anything like that, the industry, it's just the amount of energy it takes to make a windmill.
Oh, yeah.
And then
Solar
the
panel.
lubrication that is in the, for the oils, it's amazing to me.
Everything. Look at the solar panel and talk to a solar panel company about what's my payback on my solar panels if I put them on my house. 30 years. What's the lifespan of that solar panel? Between 17 and 20. What? It makes no sense whatsoever.
And again, we're not against
No.
any of this.
Because the technology at some point will get to where the solar panels, everybody will have them in the yard on the roof will be the solar panel.
Right.
It will get there. It's not there yet.
Right. Yeah.
That's something, when I think about steam and we're talking about wind and we're talking about renewables, and I thought, man, I wonder, do you think there's ever going to be, in that case, and it may be solar driven or whatever, but what's old is new. Everybody had a boiler in their house. And everyone was heating their house with boilers and then, not. But, is there a point where that cycles back around? And, people are heating their houses with steam again. And, and does solar allow that? If your whole roof can be solar panels, can you create that kind of temperature? And
I don't think they will. I think they'll convert that solar power to electric heat of some type. I think it's where they'll go. Yeah. Or they'll use electricity to run a heat pump or something like that. But I don't think they'll go back to steam or hot water to heat the house with.
I mean, I remember 40 years ago that, we had baseboard radiant heat from hot water. The dad actually put a boiler in the basement and we had hot water, radiant baseboard all throughout the house. But then there was another cool thing that he actually did a long time ago. But put coils in the fireplace to where the wood would sit, right there in the coils, and then that hot water would get heat up, and now the boiler doesn't have to turn on to actually use that hot water, so we're saving energy. At the same time, he had the air behind the fireplace, it was actually getting heat up, and he had blowers blowing out. Now, it was really dry in our house. Lots of bloody yeah, because of that, all kinds of air that's going out there. But,
Again, it's the balance. It's a balancing thing. You gain here, but you give something else.
that's the trade-off.
that's exactly right.
But think about what you were just talking about there. If people just start willy-nilly converting all their appliances to electric, and we have all this infrastructure problem, that ain't going to work either. So we really have not addressed the big problem, and that is we have to have a better infrastructure, and then we have to have a more legit plan going forward on if we're going to do all these renewables and have more electric, we're going to have to do it step by step with some logic, and the government doesn't necessarily do very logical stuff, right?
It kills me. You'll have these states that, and some of them have done it, and they're on the West Coast, but they, come out and said, hey, okay, you can't sell any more gas-powered weed eaters or gas-powered lawnmowers. It's all got to be electric. You don't have enough power to power the people now, so you tell them don't charge your cars. It's between here.
Get an electric car, but you can't choose
Get an electric car, but you can't charge it up. I mean, that stuff drives me nuts.
I think about that and I'm like, if you're going to build something, there's always going to be a period of some kind of growing pain where you can't keep up with the demand. New product, new anything, you create demand for it. Some might say, well, artificially or not, but you can't, there's not enough capacity to meet the demand. And, years ago, with boilers, was that getting coal, or was it building out the natural gas distribution, around the United States? And I wonder just if somebody had been around that long to know how long did it take to build distribution to be able to get natural gas to all this build out. I wonder if there's somebody that could look through that crystal ball and go, yeah, in about 40 years,
Right.
things seem to catch up, and they always take this long. But
I think part of the
probably was a similar pain.
Or you have a war, huge war, that forces you to do X. Like World War II forced the U.S. to put interstate systems in so you could move product back and forth to the manufacturing facilities. That's where all the interstate system was designed from.
Well, not advocating war, just to type it.
Leave that out.
We got to do what we got to do. We're country boys. We do what we got to do.
And I think another part of the problem with our grid issue is it's state by state or region by region. It's not national.
Yeah.
So it's hard to put a plan together when it's all fragmented.
Yeah. I think too, on a global perspective, I think it's difficult too that, we're trying to clean things up. Great Britain's trying to clean things up. Europe's trying to clean things up, but you have industrial countries that are just down their industrial revolution, cranking out, like in India, that is producing a ton, right? And they're trying to grow from an economic standpoint. They're not going to put.
They're not going to. We don't want to stay poor.
Stay poor.
Right.
China starting up a new coal-powered power plant every week. A new plant every week.
Right. Yeah, they were putting quite a few plants.
Yeah.
And and again, what's funny about all of that is that our atmospheres are not. It's not separate.
No.
We all share the same. The same atmosphere, and
Right.
doesn't mean we should stop and start polluting. Polluting our
We need to
country.
be more strategic and more logical about what we're doing.
Yeah, that's what my hope is that we can at some point just get logical about what we're doing instead of doing these extremes. That for the sake of saying that you're being responsible.
Yeah.
Right.
In reality, it's not. That's not what's going on.
No.
It's almost irresponsible.
It is.
Trying to do that. So, well, what about some of the, is there some emerging markets, steam powered emerging markets that you guys have seen out there, or maybe it's in developing countries and things like that, for the future? Do you see any changes with some of the other countries?
Well, like you said, India, they're rapidly going into their industrial revolution, and that's inclusive of steam and turbines and all those things. They just, they're not as developed out, so they've got a long ways to go.
Yeah, and I know that there's some safety concerns, that go on in India with some of the explosions, and so it's kind of.
Well, they got to learn like we did.
Kind of learning.
It's crazy that, there's nothing better than copying a good idea, and they're not doing that. They're not adopting the ASME design. They're not adopting the controls and the limits and all that stuff. And I get alerts on boiler explosions around the world. And there's 2 or 3 a month in India where people got killed from a boiler explosion. Yeah, there's a whole group of them that are doing everything they can to change the industry, but they're growing so fast, part of the growing pains, that they're struggling to get everybody to be on board.
Yeah, incredible engineers.
Yeah, yeah,
Very, very smart, and providing a lot of great knowledge, to us over here, in the States and around the world. What about maybe some future trends in steam generation?
biggest one going down the pike will be hydrogen, to fire the boilers with hydrogen, some type, some mix, somehow, because it's completely renewable. If they can come up with a plan to just convert water to hydrogen gas and run it through there, it'll change the combustion, the way we produce steam. Won't change steam. Has nothing to do with steam and how steam is used, how we produce it.
What about the HRSGs? Maybe talk a little bit about that.
HRSG, heat recovery steam generator. So anytime you have a power plant, a gas-fired power plant where they use the gas turbine to turn, a generator to generate electricity with, the exhaust off that gas turbine is real, real hot. So they run it through a heat recovery steam generator, produce steam, and do something with the steam to do some kind of work with it. Whether that's going to get bigger or not, I don't know. Just wait and see what the market does, what direction the market goes.
Yeah, yeah. I mean, there is some waste, I know, in these plants with heat. But there's also even waste on a boiler where the pressure may be a little bit higher, and you can turn a turbine coming off of it. I mean,
Yeah, we can feed that steam and use the turbine as a step-down regulator.
yeah,
And because most of the processes out there that we deal with are using maybe 60 to 20 pounds of steam pressure at the process. But we do it higher because it's easier to deliver it throughout the plant. We can deliver it further, faster, and get it to where it's supposed to go.
right.
But between that temperature or that pressure that we're producing and that pressure that they need, we can put a turbine in between there and then produce electricity locally for them, which is a great help to the grid, since we've been talking about grid infrastructure, that you can have it on site and produce extra electricity that way.
Yeah,
Right.
I think that's going to be one of the big expansions in the U.S. market, is those step-down
Yeah, they'll have to.
turbines.
Yeah.
To help generate power for the plant.
One of the great, I think, things that are going to be a technological contributor is, obviously we're going to probably talk about challenges and things that the workforce is aging in that area. And I think one of the great advancements is the draw that is having to happen, the migration of a younger workforce into the steam and steam generation world, whether it's on the service side, whether you're on the construction side, whether it's in a package boiler or a field erected unit, or whole everything around the infrastructure, that there's a whole generation of being our workforce that's having to be drawn in as a lot of folks age out and retire. And I think technologically, I wonder what good is going to come out of that. And it may just be the surrounding infrastructure. It may just be the ability to support it, not necessarily the technology itself. But I think we stand as an industry to gain tremendously by a bunch of fresh set of eyes on things, but also the work ethic that comes to the industry.
Yeah.
We have a lot of people coming in and discovering, I think, that I can make a really good, comfortable living, secure living for my family, and we can attract a lot of bright, smart people, into it, not into a dead end industry where, well, I'm not good at anything else, I'll just go do this. Because I'm getting a paycheck, is I can get in here, advance, and go where this industry, because as it expands, even if the fuel sources are renewable, and it's steam, that's just more opportunity.
Right.
You can't really talk about, the future as a topic, the future of the steam industry, if you will, and not talk about workforce.
Yeah.
You have to talk about Boiler University.
We have to talk about boilers first. See, another plug. We're getting better at this. You need to work it in a sentence.
Right.
But no, the future of the steam industry has to do with the people, and that's a major challenge right now.
Huge. One of the biggest issues with American Boiler Manufacturers Association we go to twice a year, and one of the biggest issues that they all bring up is qualified people, trained people. How do I train my people? All my old guys have been here for 35 years. They're all retiring. They're all going somewhere else. They're all going to go lay on a beach somewhere or whatever they're going to do.
Fish.
Fish. Ride on a trike with their wife around the country. Whatever they're doing, but they're not going to be in the business any longer, and they're trying to figure out how to knowledge transfer. How do we transfer that knowledge from that guy to the new guys, and how do we get new guys that will actually want to be in that business?
Yeah.
How do we get them in there?
Yeah. And that's what's going on, really right now that I'm seeing in the last 10 or 15 years, the change of, of what's happening in this industry. Number one, there's a lot of people going out, yes. But there seems to be a shift in that trades are something that people want to do.
They want to get back into.
This is a really good industry. I think people look at the boiler industry as a blacksmith type industry, that it's old technology, and it's really quite opposite of that. There's a huge demand for people, whether you came to work for WARE, please, or you went into the industry, it's needed, and the living is really, really good. It's hard work.
Correct.
What our guys do out there is extremely hard work. But it's very rewarding, and it pays very well. I've just seen it over the course of.
And there's so many positions in this industry that you don't need to go to college for. You can go to a trade school or go to their training facilities and learn how to get into business where you don't need a 4-year college degree to go in there and do that
Go
work.
to a great company where the training and the apprenticing is built in.
Right.
Boiler University.
Boiler University.
We talk about this.
But every kid has the right to go in debt.
Oh, yeah. Right. And then their parents get to bail them out.
Well, there was a lot, in our generation that, our parents came out of some hard times, watched their parents come out of Depression era economics and stuff, and said, you've got to go to college if you're going to make it.
Because that's the only way that you could excel.
You could make it, and if you couldn't go to college, you could turn a wrench.
Yeah.
Now, that's kind of a gross over-exaggeration, but maybe not too much.
No.
But, I love seeing, young folks that are gifted to problem solve, that like to, whether they're working with a pen and in engineering software, or whether they're working with a wrench and an analyzer or a torch, or whatever they're doing, that they know they're doing meaningful work, and getting to problem solve and work with their hands, as the phrase goes. Not because they can't go to college. That's not the end goal. Is, well, you can't go to college. You can,
Yep.
There's a certain gift and reward that comes from building out, the thing that powers the thing that makes this and that and the microphone and all that stuff. And man, I hope more young people get connected to that reality.
Yeah.
This industry is vibrant.
It's not a dead end in industry either. It's not like that. I don't want to get into that because steam's going away. I mean, we've talked about that this whole time. There's so many skills that come out of this that you'll have a job, and you'll the foreseeable lifetime should. Yeah.
However far you want to run it down, they're all going to have a job for.
Yeah.
We talked about how the boiler room is the heart of the business, even though it gets disrespected a lot.
Yeah.
You get the plant manager, when that boiler room goes down, they're all freaking out.
Super interesting.
Stopped, and then they're like, who got us up and running? That kid that didn't go to college.
Yeah.
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 Yep.
Yeah. And that kid that actually maybe even been in the industry for 4 years, in the industry that he just got that boiler running. He's actually already got a house. He's already cranking along. He doesn't have debt from the school, but he's
Funding his retirement.
put the time in and getting his retirement rolling. I think the industry is just it's a great industry to be in. It's exciting, and hopefully more and more people are looking, to the steam side of the business. And it's not just suet jobs, and it's not just cleaning the boilers out. And there's so much more to it. As a technician and even as a salesperson, there's so many things that come with this job.
Mm-hmm.
So, well, the future of the steam industry is obviously bright. We are excited about it. We think that the future is going to continue. And you can hear a lot about that right here on the WARE High Fire podcast. Make sure you tune in next time, and also subscribe to our YouTube channel and share the videos that we have. And we appreciate you hanging out with us, and we'll see you next time.